You guys really wanted to hit out of this group. And I know a lot of people freaked out on 17 because there was a negative involved. And I know some people had a hard time with 16 because the variables changed around. So let's take a look at those two together here. I expect, as I mentioned before, I was giving you guys a chance to take care of, is that everyone should have a notebook out, be copying this down as though they are part of your class notes. So when you go back to review all of this, you have an opportunity to say, hey, yeah, I got this, or no, I still don't quite get it, or whatever you need to do. So look at 16 first. We're going to be looking for the greatest common factor of 12p squared and 30q to the fifth. Now, a couple ways to approach this from what we talked about yesterday. One of the big things to remember is you're looking for common factors, things that go in to both of them. You almost know without doing any work that we're not going to have to worry about the p or the q, because there's no q in the first term and there's no p in the second term. So it's gone. It's just not going to be a factor. Now, to be complete, we should write them both down anyways. So when I do the prime factorization of 12, that's going to be 3 times 4. 4 is 2 times 2. So the complete prime factorization of 12p squared is going to be 2 squared times 3 times p squared. And that's part of the process we talked about. Now, there are shortcuts, other ways to do this. If they work for you, that's great. But if you're not sure where to start, we start with the process of prime factorization, write it out. Now, let's do the other one over here, 30. How do I get to 30?
6 and 5.
6 and 5? And then 5 is prime. 6 is 2 and 3. We'll write that down in order. See, it all still worked out nicely in order. So 30 q to the fifth is the same as 2 times 3 times 5 q to the fifth. And now I compare and I look for things that they have in common. So I look down the 2's, they both have a 2. I look down the 3's, they both have a 3. 12p squared doesn't have a 5, so that I don't use 5's. I don't use p's, I don't use q's. So I'm left with just 2 times 3 or 6. Okay?
Wait, what if you
Hang on, Sasha, go ahead.
What if you did that for 12 you did 2 times first?
You know, you're factoring 12. What if you had done 2 times 6?
No, 2 times 4 times 4.
Well, because 12 is not 2 times 4.
Yeah.
12 is 3 times 4, which is what we have here. Or you could do 2 times 6. But when you do that, 2 times 6, 6 is 2 times 3. You're still back to the same prime factorization of 2 squared times 3. Sasha?
Is there any other way to do this that saves like 8?
Not really, unless you start to get good at spotting the common factors. Like after you've done this for a while, you can look at 12, which 6 divides evenly into, and 30, which 6 divides evenly into, and pull that out of both of them, and then see what you're left with to see if there are other things there. And so you don't have to do the full prime factorization. You can just factor out numbers you know they have in common. For those that are still kind of like feeling this out, kind of ignore this for just a second. If I take 12 and 30, well, I know that's 6 times 2 and 6 times 5. There's my common factor of 6. And the 2 and the 5 aren't in common, so drop them out. But the key to that working is you have to get comfortable with all these factors and products. And for students that are not comfortable with that, the complete prime factorization, laying them all out, is guaranteed always to work.
Okay, I'm having trouble. Will you go to the top really for the homework?
I can't from here. But I can go back to those problems in a little bit.
Okay, well, on the top, when you do that, whatever you're asking for on the top, when I would do the trees, I didn't know how to use them.
Okay. When we're done with these 4, we can go look at those. Those 4. All right, so 16's knocked out. Let's talk about 17, because that's another one you guys asked for. And then we'll go back, we'll look at those first couple problems, and then we'll get into today's stuff. 17.
Do we have homework today?
Absolutely, we have homework today. Let's see, it says negative 6t to the third, and we're comparing that with 9t. the negative appears to have thrown you guys. When I factor 6, what do I get? 2 and 3. Well, it's a negative, right? So 6 t to the third, prime factorization is negative 1 times 2 times 3 times t to the third. And then when I do 9t, the prime factorization, well, 9 is 3 times 3, so I get 3 squared t. So I look for what they have in common. The negative 1 is not common. The 2 is not common. The 3 is, but just one 3. So write that down. And then the t. So that must be my final answer. Now, getting to Sasha's question, is there a way to do it with less ink involved? Yeah, especially when it comes to the variables. It's always going to be the variable with the lower of the two exponents. So since this guy over here had an exponent of 1, and this has an exponent of 3, I know that my answer is going to be t to the first. That's the rule. And then when it comes to the numbers, well, what divides evenly into both negative 6 and 9? 3 does. Rudy?
Can't you just do 2 times negative 3?
Sure.
Okay, can you do it that way?
Sure. Just, you want to be careful to be sure that you don't say, oh, look, there's a negative 3 here. There we go. There's negative 3 here if you write that way, and not see that this 3 and this 3 are the same number, which has to end up down here.
Wait, can you combine the, let's just say the top one was negative and the bottom was positive. Can you combine them?
Just pull down that common 3. They both have a negative 3 and positive 3 have a common factor of 3. So you gotta make sure that 3 comes down with the common factor.
Okay, so...
Okay, what?
So, like, if you have that side, you would have 2 times negative 3, right?
Uh-huh.
When you're combining them, you have,
So you're not combining them, you're looking for commons. So if you write this, 2 times negative 3 and 3 squared, you still have to say, oh, hey, there's a 3 and a 3. So in common, there is still a 3 to be considered.
it's because the positive always wins.
Right. Well, because they both have, negative 3 is negative 1 times a positive 3. Technically, if you're doing a full prime factorization with negative numbers, you really should be writing that negative 1 all by its own sum.
What is negative 1 do?
It's negative 1. So negative 1 times 2 times 3 would give you a negative 6. So technically, the true prime factorization should have that negative 1 separated. Or it doesn't work so